This is the beginning of our work on differential equations, and we're going to be looking at differential equations of the first order. I've written an equation y equals 2x cubed, and that's something that you know that you can differentiate. So if we were to do that, we would find that dy by dx is equal to 6x squared. And dy by dx equals 6x squared is an example of a first order differential equation. Unfortunately, there are many other equations that would also differentiate to y equals dy by dx is equal to 6x squared. For example, y equals 2x cubed plus 1, y equals 2x cubed minus 7. All three of those would, when differentiated, arrive at dy by dx is equal to 6x squared. And what we're trying to do in this unit is work out ways that we can find the solutions to these first order differential equations. And it looks as though any equation that begins y equals 2x cubed and then has a number either added or subtracted, plus c in general, would be the solution to the differential equation dy by dx is equal to 6x squared. And that last one that I've written we call the general solution. And if we have a little bit more information so that we can work out the value of the c, then any one of these would be called particular solutions. And you're going to be using your skills of integration in solving differential equations to find general solutions and sometimes particular solutions to these first order differential equations. So we've seen that to solve a differential equation, we're basically doing the reverse of differentiation, we're integrating. So if dy by dx, the differential equation, is some function of x, then y will be found by integrating that function. And we can see that in a fairly simple example. So if I have dy by dx is equal to 3x squared plus 8x, then I can say that y will be equal to the integral of 3x squared plus 8x dx, which I can now integrate term by term. So y will be equal to 3x cubed over 3 plus 8x squared over 2 plus c, which we can simplify to y equals x cubed plus 4x squared plus c. We've arrived at the general solution of our first order differential equation in that final line there. In order to find c, we would need a value of x with a corresponding value of y, which we weren't given in this particular case. In this example, where we're solving x squared plus 2x dy by dx equals 3, we're going to begin by moving that bracket across to the other side. So dy by dx is equal to 3 over x squared plus 2x. We can factorise the denominator to give us 3 over x brackets x plus 2, and then we can further split that into two partial fractions, a over x plus b over x plus 2. You might like to pause the video at this point and go away and see if you can find out the two values for a and for b. You may have come up with something like this. 3 equals a brackets x plus 2 plus bx. And then if x is equal to 0, 3 is equal to 2a, so a is 3 over 2. when x is equal to minus 2, the bracket x plus 2 becomes 0, so 3 is equal to minus 2b, and b is equal to minus 3 over 2. And so our differential equation becomes dy by dx is equal to 3 over 2x minus 3 over 2x plus 2 in brackets. Now that's in the form that we noted before. Dy by dx is equal to a function of x, and that function of x is in a form that we can integrate. And that's what we do next. We're going to integrate throughout to give us y is equal to the integral of 3 over 2x minus 3 over 2 brackets x plus 2 dx. Integrating those terms in turn, we have y is equal to 3 over 2 ln x minus 3 over 2 ln of x plus 2. Those two ln terms we can put together for convenience, and we have y equals 3 over 2 ln of x over x plus 2 plus c. And we've arrived at the general solution of that differential equation. But now let's imagine that we had a value of x and a value of y. So when x is equal to minus 3, y is equal to 0, we can now go on to find c, and we'll end up with a particular solution to this differential equation. So 0 is equal to 3 over 2 ln of minus 3 over minus 3 plus 2, and 0 is equal to 3 over 2 ln, and I've got minus 3 on the top and minus 1 on the bottom, so ln of 3. So c will equal minus 3 over 2 ln 3. Now I can put that all together to give me my particular solution, y equals 3 over 2 ln of x, x plus 2 minus 3 over 2 ln 3. And again, using laws of logs, I can combine the minus 3 over 2 ln 3 in the first ln term to give me y is equal to 3 over 2 ln of x over 3 brackets x plus 2. And there is my particular solution.